This is Accelerated Geometry, section 3.5. We're going to be constructing parallel lines. Here are some pictures of some parallel lines, train tracks, and then drawn ones. Okay, we review the definition of parallel lines. They are lines in the same plane that do not intersect. And so that would be this set over here, this set on the right. And then it says, there are many ways to be sure that lines are parallel. And we learned some ways to do that in chapter 2. So we had if corresponding angles are equal, when two lines are cut by a transversal, then we know that the lines are parallel. If we have alternate interior angles that are equal, then the lines will be parallel. If alternate exterior angles are equal, then the lines are parallel. If same side interior angles are supplementary, then the lines are parallel. And if same side exterior angles are supplementary, then the lines are parallel. So what we're going to use out of those 5 conjectures, we're going to use 2 of them today. So the first one we're going to use is this one. If 2 lines are cut by a transversal so that corresponding angles are equal, then we will know that the 2 lines are parallel. So there is a video of this, and here is the link to it. And if you click on that, there will be a person there showing you this. And then I myself am going to show you this also. As always, there's a set of directions. You can follow these directions as you watch these videos. So you can also follow these directions as I do the construction. So it says start with a given line and a point P that is not on the line, and then draw a line through P, and you want to draw that line through P so that it becomes the transversal, and then you're going to duplicate that angle that you create there, PAB, at P up above, creating corresponding angles that are equal. And if the corresponding angles are equal, then the lines are going to be parallel. So I'll put this down for a while, and I will do this construction. So I have one line here, and I want to create another parallel line that goes through that point up there. So through that given point, I create what's going to be my transversal. And in my mind, I think, where is that parallel line going to be? It's going to be about there. That creates an angle here and an angle here that are corresponding angles. So if I could get both of those angles to be equal to each other, to copy one onto the other, I would know where my parallel line would be. So I am going to copy this angle. So I stab in at the vertex, and I go through both sides of the angle. I stab in at this vertex, and I go through 2 sides of that angle. One of them that I know, and the other that I'm kind of guessing at. That really doesn't exist. That dotted line is just a little helper line. Okay, then I open up my compass to how wide the opening is, that far away from the vertex, and I come up here to this one and stab in there and make an arc that goes through there. And when I connect those two, the arc intersection and the given point, I have a line that is parallel to this first line. And the reason is, if I can create 2 angles that are corresponding angles and equal to each other, then I know that these 2 lines are parallel. Okay, then I'm going to go back to the presentation. And this next slide says, or we could use a different conjecture. If 2 lines are cut by a transversal so that alternate interior angles are equal, then the 2 lines will also be parallel. And again, I have the steps on the next slide. I'll show you these in a second. And you can see this construction done by clicking on this link here, or you can always go to my CMH Accelerated Geometry Links, Chapter 3, and then the construction is 3.5, constructing parallel lines using alternate interior angles. Okay, so here are the steps. So again, I have the point and the line. I draw my transversal through that point P, and then I create two angles that are alternate interior angles and are equal to each other. So here is the construction where they're doing that. And then at the end, you have created, because you have these two alternate interior angles that are equal, you know that these two lines are going to be parallel to each other. Okay, so I'll put that down now and go back to my drawing here. Okay, what if I have this line here and this point P again? So I come through that point and this line, and I want to create a line through that point that is parallel to that first line. So it's going to look something like this, but I don't know exactly where it is, so I have to construct it. Okay, I'm going to use alternate interior angles. That would be this angle and this angle, interior inside of the parallel lines. Alternate means on opposite sides of the transversal. So I'm going to copy this first angle up here, and we'll get congruent alternate interior angles. So I'll go through here. That's how far away from the vertex I'm going to be measuring the opening of the angle, and through here also. Then I go back to the first angle and open up my compass that wide at the opening, and then I stab in here and make an arc. So I have now copied that first angle. I didn't do a very good job of doing that, but you get the idea. There you go. Okay, I have now copied this angle over here, so I now know I have alternate interior angles that are equal to each other, both of these guys here. And because alternate interior angles are equal, I now can say I have constructed parallel lines. So that is the lesson for today, and you can now turn off this video and start working on the homework.